In this problem, you're going to identify the limiting reagent. And after you identify the limiting reagent, you're going to calculate the percent yield. So before we begin, in order for you to do these problems properly, you have to be very good at the stoichiometry that we did previously here. Remember these. So make sure you're good at it. Right here, that's the shortcut. Use it, whatever it is. So let's start, because we're going to do it actually twice, this grams to grams. Once again, it can be from moles to moles as well. So the question always is going to give you the actual yield. So as we can see down here, right away, we identify this. As the actual yield. It says if 3.52 grams are actually formed, what is the percent yield? And the question is asking for how many grams of ammonia can be produced theoretically. So you're looking for the theoretical yield from the reaction of 5 grams of N2 and 5 grams of H2. Very well. So here's what you need to do. You need to take the grams of N2 all the way to the grams of NH3. That's what the question is asking. It's asking you to, if you're given two amounts for these two reactants, 5 grams of N2 and 5 grams of H2, how much NH3 can be produced, or how many grams? And you also have to do that with 5 grams of H2. Now, I'm going to tell you one thing is that the last conversion factor here is going to be the same because you're ending with the same grams of the sample, okay, or you're ending with grams of the sample, so the conversion factor is going to be the same. Doesn't mean that the amount will be the same because we have different starting amounts. So again, we have 3 conversion factors since this is a grams to grams. So if you recall, anytime we see grams, we have to calculate the molar mass. Now, again, check these on your side. Again, this is from the periodic table. So we have 2 atoms of nitrogen. So that would be 28.02 grams of nitrogen, 1 mole of nitrogen. Now, again, where did I get this from? Here it is, 14 for an individual nitrogen atom, but we have 2 of them, so that would be 28.2. So again, from now on, we're going to just calculate this and you can verify it from the periodic table. The next thing is we need some ratios. So let's look at the ratios. Easy if you write it on the top. So we have 3 to 1 to 2. Now, I'm dealing with N2 and NH3. So that would be 1 mole of N2 to 2 moles of NH3. So again, moles of N and 2 should be on the bottom so they can cancel out. And the 2 moles of NH3 should be on the top in the numerator. And finally, you're ending with the molar mass of NH3. So that would be 1 mole of NH3. They can cancel out, and then find that from the periodic table, this would be 17.04 grams of NH3. So that would be 5 times 2 times 17.04 divided by the 28.02, which gives us 6.1. For the grams of H2, you should probably pause and do this problem, but I can tell you right away that this is going to be the same here if it's, again, grams to grams. So you should fill in what goes in here. So you should pause and do that. It's really helpful. Okay, so this would be 2.02. That's the molar mass of H2. 2 hydrogen atoms, 1 mole, H2. And the ratio of hydrogen to ammonia would be 3 to 2. So that would be 3 moles of H2 to 2 moles of NH3. And the answer for this would be, let's calculate it here, 28.1. Now, what is the answer? What's the correct answer? We have two different amounts. Well, it's the smallest, just like when you go back right here and you pick the one that gave you the least amount, and that would have been the meat because the meat runs out. So in this case, quick, this would be our theoretical yield right here. One way of looking at it is by visualizing it in case if you use your 5 grams of N2 and you use the 5 grams of H2 to make 6.1. So this is 6.1 grams of NH3. The 5 grams of H2 would make you 28.1 grams of NH3. But the question then comes, okay, think about it. If the N2 runs out, once you make 6.1 grams of NH3, where the heck is the rest of the N going to come from to get to 28.1? After all, again, ammonia has both the nitrogen and the hydrogen. So think about that. So again, this would be our correct amount. Now, to get the percent, to do the percent yield, what we would have to do is simply take the actual yield, which is given to us in the problem, okay? Let me just erase this here really quick. So that would be the actual yield divided by the theoretical yield times 100 The actual yield was given to us. It was 3.52 grams. This is always given to you. Divided by 6.1 times 100. Which is to two significant figures, that would be 58%. Generally, a good percent yield is the one that is as close as possible to 100%. Of course, it's never 100%. So this is in between. Not bad, but it could be better. So the next problem, we should work on this one. This one has pounds and kilograms. So it's going to involve more dimensional analysis, but it's a good practice. Work on it. Please finish it. And then we will do it when we meet on Wednesday.